Imagine standing in the middle of an open field. The air goes completely still. You look up, and the sky above starts to spin. It's a terrifying scenario that raises a specific question. What would happen to your body if pulled into that vortex? Thrown into the sky? Crushed by sheer physical force? Or is there a perfectly calm sanctuary hidden deep inside the storm? To figure out what happens inside the chaos, we first have to zoom out. A tornado requires a massive, coordinated atmospheric machine to spawn it. Inside a supercell, warm air rushes up, while cool air sinks. Winds at different altitudes blowing in opposite directions create wind shear, rolling air into a spinning horizontal tube. The strong updraft tilts the spin vertically, creating a massive rotating column. Eventually, the circulation drops below the storm clouds. But even seeing a massive funnel in the air doesn't mean it's officially a tornado. The exact second that spinning circulation makes contact with the Earth, the title changes. You have a tornado, and the atmosphere becomes instantly weaponized. So let's step inside. If you were caught inside that circulation, you might expect to find a calm center, similar to the eye of a hurricane. That is a myth. While wind speeds might technically be lower at the absolute mathematical center of the vortex, the environment around you is completely unstable. The winds change direction rapidly, and the entire core shifts across the ground. This animation shows what is happening to the air pressure. Because the air is rapidly spinning and being sucked upward, it creates a vacuum effect. The atmospheric pressure near the center drops dramatically. But we need to clear up a major misconception. This sudden drop in pressure is not what causes houses to burst. That is an old wives' tale. The pressure difference alone doesn't destroy the building. The kinetic energy of the wind and flying debris does. The strongest tornadoes produce winds estimated at over 200 miles per hour. At that velocity, the air acts as a high-speed blender, shredding anything caught in the circulation. The wind itself is only part of the threat. The circulation picks up dirt, branches, broken glass, and entire pieces of furniture, accelerating them into lethal projectiles. When these projectiles slam into a house, they shatter windows and punch through walls. Once the building loses its structural integrity, the wind rips the roof off, leading to sudden, total collapse. In the movies, tornadoes casually throw massive trucks hundreds of meters. In reality, moving a vehicle requires a precise combination of extreme wind shear, sudden pressure changes, and the car's exact position on the ground. Then you introduce the compounding nightmare of multiple vortex tornadoes. Instead of one solid funnel, several hyper-intense mini-vortices whip around the outer edge of the main circulation, creating pockets of absolute destruction. This is why surviving inside the circulation is nearly impossible. Visibility drops to zero. There is no safe direction to run and no escaping the shifting field of debris flying at you from every angle. Once the storm finally dissipates, we can examine the macro view of what it leaves behind on the ground. The sheer friction of the wind and flying sand strips the bark from massive trees and shears away every branch. From above, these damage paths cut localized, sharp lines through entire towns. They look as if a giant, invisible brush was dragged directly over the map for kilometers. This permanent geographic scarring is caused by a phenomenon that, in many cases, only existed for a matter of minutes. This reveals a massive gap in our understanding. Even when scientists track the exact ingredients needed, the wind shear, the atmospheric moisture, the vertical updrafts, predicting the specific moment of formation remains a mystery. Forecasting is challenging because the final trigger depends on microscopic, chaotic changes in airflow near the ground. It is nearly impossible to track these tiny variations within a massive atmospheric system. You can have two massive supercell thunderstorms developing right next to each other under the exact same conditions. One will pass harmlessly overhead, the other will suddenly drop a monster. Because of this unpredictability, old survival myths, like cracking windows to equalize pressure or trying to outrun the funnel, are dangerously foolish. The only sound response is to find immediate shelter. The next time you see a dark, rotating cloud gathering on the horizon, remember what you're looking at. This is the atmosphere becoming an unpredictable monster.